Good afternoon, everyone. My name is Inaba from Line. So I'd like to talk about the technologies that support the distribution of Line news articles. So I'd like to talk about the Line news articles, especially the personalized recommendation distribution. So who is using Line news on your everyday life? So maybe 50% of the people. So other half have not used Line News. Maybe you can start using Line News after my session. So before talking about the agenda, let me introduce myself. Well, I joined the company 2 years ago, and I usually am in charge of the server side of the development for Line News. This is my agenda. So first, this is sort of the first time to talk about the Line News in an official way. So I'd like to first overview the Line News. Maybe the services and also scale of the services that will be covered. So after I talk about Line News, I'd like to talk about the recommendation distribution. That's the core of my session. So first of all, let me overview the Line News. Line News was launched in 2013 as web native application. So this is the 7th year, which is quite a long project in our company. And in 2017, within Line application, we have embedded the news tab. So maybe when you hear Line News, maybe this is the first thing which came to your mind. And now, so we also have started some collaboration with the external media companies. So we have gone through several major events in Line News history, but I don't think this is the topic in this session, so I'd like to skip that. So since 2013 till now, we have expanded the services with this Line News, but other than news, we have distributed different contents, such as weathers and transportation, which are quite useful information in your lives, and also citizen emergency protection or maybe evacuation information, and also earthquake information, and also maybe their football or baseball live distribution. That's another one. And also, if you are registering your regular routes for the transformation, you can actually see the delay information of the specific routes on the news tab. So maybe you can try that. So how many users are using Line News? Monthly basis, 68 million active users and also 12 billion V. So quite a lot of users are using Line News. So in terms of the traffic, how this is turned to be is on the daily request, it's about 17 billion, and per second request at peak time, 375,000 and also 200,000 on the average. However, I just happened to choose the specific weekday, so maybe if we have a big news on the particular day, I'm sure that the numbers are bigger. Well, for your information, this is a traffic fluctuation throughout the day. So 12 noon and 2000, you see quite a big peak. So maybe you are checking Line News during lunch break or maybe on the way home. It's quite interesting. So, as a news application, I think we have received quite a big traffic, but this is an infrastructure which is supporting that traffic. As an application server, Amon2 Pro-made framework, we have 44 servers of them, and also there are 30 servers which are running Spring Boot. Some of you may wonder why Pearl. I'm sure that you are wondering why Pearl. Yes, at Line News, we still use Pearl. And this is, of course, the legacy or history or heritage. We started to migrate to Java, so recommendation distribution system is fully implemented on Spring Boot server. So DB server, MySQL, we have 3 of them, and also MongoDB 21, and cache server, Memcached server, we have 44 of them. Redis, Sentinel configuration, we have 3 of them, and also 1 cluster configuration. Memcached is for Perl, and Redis is for Java. Other than these, we have that server and also CMS server, RSS, SFTP, SOAP, and externally orchestrated servers. So we have quite a different kinds of the servers. So on top of these infrastructure, Line News, we are using, we are importing for the external, and also we have the processing for the body of the news, and also we are delivering the message. We cannot spend time to go through the details, so I'd like to focus on this personalized recommendation, which could be quite interesting in terms of that technology. So I think that's about the overview of Line News. So now let me talk about how Line News are distributing the article recommendation to the users. I think this is the biggest article data and also user data to bring the recommendation, so that Line News is full of information which is interesting to the specific user. So for that purpose, we are delivering the personalized news or recommendation to each user. So maybe when you open the news tab, you see the recommendation on the top, which is a left-hand side, far left. So Line News recommendation is not just using machine learning recommendation, but we use manual recommendation by our operation team. So to the users, it's a mixture of the 2 kinds of these recommendations. For machine learning, the automatic recommendation and also manual recommendation. Maybe you may wonder why, but this is trying to deliver the articles which are more interesting to the users. So we have a quite passionate about delivering the personalized users. But when you hear the manual recommendation, you may not know what this is. So let me explain a little bit more about this manual recommendation together with the machine recommendation. This is a machine learning recommendation. The creating the recommendation is not done by Line News, but this is by our internal machine learning team's recommendation. We are trying to get that. Recommendation is delivered in multiple split files, and over 100 million users equivalent recommendations are stored. When you hear 100 million, this is far more than MAU of Line News, but recommendation itself is not just for the purpose of Line News, but we have to generate the equivalent number of the Line users. So that's why we have this number. And of course, when you are opening the news tab for the first time, you have to see something. So that's why we have to create this much. For recommendation, we have 200 article IDs for 1 user. So total is 100 million multiplied by 200. So that means 20 billion articles IDs are stored, and that file is updated in every hour. So we need to import 20 billion article IDs in every hour. On the other hand, manual recommendation. This one, the Line News operation team is setting up this in CMS. The setup is by age, gender, or prefectures, and we combine different attributes. For instance, the male in 20s living in Tokyo and Kanagawa, we deliver this type of article. So which media the user is following, we can specify that. So let's say the sports media is which they are following. Maybe we can deliver the baseball-related news. The recommendation, we can actually set up recommendation in parallel, and also we can set up the specific period, how long it can be displayed. So among those recommendations, I think users will see the targeted news as well as the targeted period together with the other machine learning enabled recommendation, and also which position should we display. That can be also set up on CMS. So these two types of recommendation is not starting from our starting point. We have not really started the hybrid from the beginning, but at the beginning we only offer the recommendation using machine learning, and after later stage, we have implemented the manual recommendation. We had some issues in initial implementation and also system configuration, and that's how we come to this combination of two types of recommendation. So first, machine learning recommendation. Let me talk about what we did. Recommendation distribution processing, we have two steps. One is request processing, the other is import processing. First, let me talk about the request processing. So before recommendation was implemented, the request process of the line news was something like this. So pages have to be displayed quickly, so we use CDN. So the article page, of course, depending on the users, we did not change the content. So those are dependent on CDN. So once recommendation is introduced, of course, we have to put there certain parameters to identify the users on the request. Servers, depending on the parameters, have to respond. So it is not possible to use CDN. So because of that, every time request is coming, we have to do certain processing on the origin side. And on this one, what we did for the line news is something which I'd like to touch upon.
First of all, here is the architecture. Let me describe the event flows. This part I will come back later for details, but the machine learning team generates recommendations which are pre-imported and Redis cluster. When the user sends a request, first of all, from Redis cluster, we have to fetch the list of recommendations, which is a set of article IDs. Once you acquire the article lists, Redis Sentinel receives mget operations. Redis Sentinel has cached articles information. Mget is multiple get. Multiple keys can be sent. It's very handy. However, it doesn't work on cluster. The articles which was not found in the cache will be obtained from MySQL. Such information from MySQL will be cached on the cache server. So the article, which is viewed by multiple users, once it is acquired from MySQL, the next time around, the load is very fast because it comes from cache. The article information acquired from both Redis and MySQL will be sent back to the user. So, how much of article information is acquired from MySQL and Redis? The graph shows minute by minute. Yellow line is Redis, and green line close to very much like 0 and nil are MySQL. With this, you would understand that most of the time, articles are fetched from cache. MySQL runs about 5,000 at the peak time, whereas Redis is 8.2 million. Actually, cache server network bandwidth is largely consumed by doing this, and we have once caused a jeopardy when application servers failed because of the large use of the bandwidth. But I will not talk about that today. Now, having said so, the personalized user request processing itself is not that difficult. The previously presented architecture would not strike you as odd or special. That's right, because the challenge was on the part of recommendation import. So let me then now talk about that part. So, what are the challenges of the import issue? The biggest one is this. We have to hourly import recommendations for 100 million users. So, what did we do about it? Once again, let me start with the overview according to the flow of the event. When I talked about recommendations generated by machine learning, I said that there is a team called Data Lab issuing recommendations. After the recommendation file is generated, Data Lab team uploads that to Data Hub, a storage server. Once it is complete, notification API is called on the part of line news. API server receives the notification from Data Lab. Then the request is sent to 3 servers, 3 importers, and each importer has APIs which are called in this setting. At that time, each importer knows the range of the recommended file to be imported with limit offset method. 0 to 100 to importer 1, 100 to 200 for importer 2, and so forth. Each importer, based on that limit offset, imports recommendations from the Data Hub. Let me deep dive into the import process. When the import process runs, first of all, the first file is downloaded. File is TSV format. So it looks like this. User ID, article ID or list of article ID, and a list of scores for article IDs, separated by tabs. And comma is used to break the article IDs and score lists. Article ID and score are indexed. Each line is parsed to look like this. To generate the combination list of user ID, article ID, and the score, and converted data will be stored in Redis using user ID as a key.
So from this file download to store in Redis, those series of the processing is in 20 threads. It's asynchronous and also implemented in parallel. And 3 servers are running, meaning that a total of 60 threads implementing or executing this. This is how we import the 100 million people's recommendation in every hour. It takes about 10 minutes to process this import. So I think we have quite a good capacity. So that's all about machine learning recommendation. Lastly, let me talk about the entire processing of request and import. Request is something like this, and import is this. So machine learning recommendation is running, no problem, on this architecture. So now let me talk about the architecture, which also adds the manual recommendation. The manual recommendation, as I said, there was some problems in the initial implementation for the manual recommendation. So first, let me talk about the initial implementation and also its problems and how we overcome the issues. And that's the flow of my rest of the presentation. So let me recap the manual recommendation. The operational team is setting up on CMS and the targeted users with the combination of the different attributes are selected. You can set up how long and when we can actually display and also at which position we can display the manual recommendation amongst the other machine learning recommendation. So first, let me talk about the initial implementation, our first approach. In the initial implementation, we were trying to have the system to extract the user ID from attributes. We did not have much time. So for that part, we decided to do the manual operation. In terms of the system, the targeted user ID list, which were extracted prior, to be uploaded in CSV format. Let me show the architecture. This is the entire architecture. This is import and this is request. So let me take you through with the flow of the data. However, before talking about that, there is a central dogma, the component called central dogma. We have developed the system central dogma on our own, and this is quite an important factor in the entire architecture. So let me explain what this is. So central dogma is simply stated, this is the repository system which are trying to centralize the setup files. Setup file meaning JSON or YAML files. So this is really important in the entire architecture. The client of central dogma can watch the files on central dogma. If there's any change in the files, the latest information will be stored on client side. Based upon that understanding, let me take you through the architecture. Data lake stores. Data lake is the large-scale internal Hadoop cluster storing the user information. So Line News is using that information for the manual recommendation. So if you want to enter the manual recommendation, first we have to deliver the attribute information about the users which we want to be extracted. And that data analytics team is getting that information to build the SQL and trying to extract the IDs. And then operation team is going to have the list in the form of CSV file to upload to CMS. So which article, how long, and also where to insert, that information also are entered. So CMS server will the articles and also user mapping data will be stored on Redis. So mapping data is in this kind. So the article ID is key and user ID, which is extracted from CSV, are set as value. User ID is about 30 bytes character strings. So for instance, 10 million users to set up the recommendation, 30 by 10 million, so it's 300 megabyte for one article. So matching data, if you are successful in mapping data, then you are going to store that information in MySQL. And then that server is checking the MySQL. And if there is any recommendation article within the specific time frame, that article information will be uploaded to Central Dogma. On Central Dogma is uploaded with this kind of JSON. Titles, images, machine learning recommendation, where it can be inserted. We have far more information in reality, but this is showing what kind of information is stored so that we can deliver or distribute the recommendation articles to the users. The central dogma client is detecting the change in central dogma, and they store the data on client side. So web server already has the article information. So if there is a request from the user, first, from the Redis, we get the article ID for that user. So let me tell you how we do it. So this kind of mapping data is there. Then from here, user ID 1, we first, if we want to get the recommendation information for user 1, then to all the keys on Redis, sys member operation is completed. So in the value set, if this sys member operation is trying to see if there is any specific value in the value set. If user ID 1 is included, then article ID 1, 3, and 4. That's article IDs. And this is the recommendation ID for user ID number 1. The detailed information about the article is already stored on the server by central dogma client, so it doesn't have to go through the network. Based upon that information, we mix that to the machine learning recommendation to respond to the users. So that was the initial implementation. As was mentioned before, this implementation had a problem, and let me talk about what problems we had. So, mapping data format, we could not scale because of the mapping data. Even though we distribute on the clients, well, we have about 300 megabytes per one article, so we could not leverage the benefit of a cluster. 20 million users, that means 600 megabytes. So if we do this type of recommendation over and over, cluster may not work. But unnecessary article can be removed quite easily. So article ID is the key. So from the Redis to just remove or delete the applicable ID will suffice it. However, manual recommendation, the number of the manual recommendation was far more than what we expected, so scaling is the issue. And the other is the operation cost is too high. The target is because of the manual operation, so extracting itself is really a big issue. And when we are doing the target change, I think it is quite costly. I think you have to have the SQL. So again, if there's any change in target, then we have to change the SQL, and that will put a burden onto the data operation team. So how we address that issue is something which I'd like to cover now. And the mapping data format lowers the scalability. And of course, mapping data format can be changed to address that issue. So how we change is something which I'd like to touch upon later. And the next one is the operational cost was too high, and the target user ID extraction via CMS can solve that problem.
I would also like to start with the overview. This is the import side, and this is the request side. The changes from the earlier architecture is the highlighted part on this slide. Mapping data format has been changed on the request side, but that's the only change. Let's start with the initiation of this event. With the previous architecture, the operation team would ask the analytics team to do some manual work. Now, from CMS, operation team can now enter combination of target attributes. The CMS server receives that input and then stores the article information on MySQL just like before. And newly added is the manual importer, a server which receives the target attributes input from gRPC. The importer builds SQL based on that information and extract user ID from a data lake. The work that's been manually done by the analytic teams previously. Why don't we do it from CMS directly? Well, extraction of the user ID can take up to 1 hour, depending on SQL, so we decided to have a dedicated server for that purpose. When we complete the user ID extraction, user ID and article ID mapping data is saved in Redis cluster. The mapping data format uses user ID as a key, and the value is article ID as a set. With this, the data size per key can be reduced so that we can save mapping data without jeopardizing the benefits of Redis cluster. When it is done, MySQL has a flag, valid and invalid, two types of flags. And after that, no change. We have batch to upload the displayable article information to Central Dogma, and Central Dogma client saves that information on servers. Redis cluster acquires recommended articles and insert that information to the machine learning generated recommendations in appropriate positions. So, the recommended article ID was extracted with great efforts earlier, but changing the mapping data structure, it has become extremely streamlined. With this architecture, we enhanced scalability as well as large reduction in operation cost. On the other hand, with this change of architecture, there were some penalties. So I'd like to talk about that before I move on to the outlook of line news recommendations going forward. First of all, some penalties. Mapping data generations and deletion have become a little difficult. For example, article ID for user ID 345. This is a setting you want. With the earlier format, this type of a mapping data was already existent, and you would go for the setting on Redis, exactly like this. On the other hand, in the new mapping data format, newly added user ID, you can simply set it like this. However, if you have users with some recommendation already set, within the existing value set, that new article ID sets have to be inserted. A third operation can be done quite easily, but you have to repeat it. The number of users who would receive these recommendations, quite complex from the fact. The deletion of the mapping data is the same story. Article IDs to be deleted, and the number of articles with the same number of keys that have to be deleted, quite cumbersome. But in terms of performance and scalability, we have been able to enhance both of them with the current mapping data format. Now, let me talk about future plans for the line news recommendations. I'd like to touch upon two of them. First one is, of course, improvement of the recommendation quality. What is the quality of recommendations? Well, that is something that can be improved by the user response, like impressions. And such a feedback is reflected in the next round of recommendations. The existing Line News recommendations will allow user response to be received anytime. However, the improved recommendation can be reflected only after 1 hour, because recommendation import is done in hourly batches. User constantly sends us responses and we cannot really leverage it. So, well, I said it's a future plan, but this is something already being done. That is, we are implementing new recommendation engine called AIRS. With this, you don't have to process import on Line News. Users will constantly receive improved recommendations real time based on user responses. This is only applied to a part of the users in A/B test format. Line News will continue to take various measures to enhance quality of the recommendations. And number 2 is enhancement of the improvement or recommendations to digest. Line News distribute digest, and this is where we may be able to implement recommendations. Digest is sent to all the users in the one-size-fits-all format, and digest contains the best of the best news which has been handpicked by Line News editing team. But together with recommendations, we can further improve the quality. For all the users who are friends to Line News official account, we may be able to push different content to each and every one of them. When it is done, I think there will be another interesting story to tell you. Today, I focused on recommendation distribution in Line News features. Machine learning generated recommendation is combined with manually generated recommendations. I talked about how requests and import are implemented. I hope you enjoyed my presentation. But as I mentioned earlier at the outset, Line News certainly delivers other contents than recommendations, and we will further enhance our contents going forward. So, the takeaway today is please use Line News. With this, I would like to conclude. If you're interested in details of what I said, or if you're interested in any part of Line News that I didn't talk about, please join me at Ask the Speaker section of this room. And also, we also have a booth where Line News engineers are waiting for you to stop by. Thank you very much for your kind attention.